Imagine the following scenario. You are building your current plugin project. You are closing the window. The build stopped. Now you open some folder and open a file that was just created during that build. And this file shows a lot of numbers. The time it takes for a process block to finish in microseconds. Mostly the same number, but there are some outliers sometimes. But you are not interested in each of the number, but mainly in the statistic at the end. The quickest time was 226 microseconds, but it can also take 884 microseconds. On average though, it stays on the minimum speed. That sounds pretty good to me. It works like this. I have this benchmark namespace that just has a free function called ProcessBlock, and when you are giving it the current audio processor, then it will do this test. I will not show you immediately how this method works though, because that would be no fun. Honestly, you could just scroll forward to the part where I explain it and think to yourself, haha, checkmate. But you wouldn't do that, right? I promise, it will be fun though. Most of you probably know the C++ playlist from the Chrono because it's the best resource for learning basic C++ ever. He has made a lot of videos, and one of them is about how to use std chrono to benchmark something. Maybe it was timing in C++, yeah. Maybe. Yeah, it was timing. Anyway, what he shows in this video is that you can just make a class where you are storing the start time the moment the object is created, and then you are getting the distance in time in the destructor. In the tutorial of the journal, I think he just printed it to the console, but it would be more interesting to read it out into a file or something, because then you could just, have an object of this in ProcessBlock, and then you know how long it takes to finish ProcessBlock, and then you just have to find a way to get that into a file. So my first approach to this was like this. I have an atomic duration, which is an atomic of an std chrono duration double. And it's atomic because it's accessed by both the audio and the message thread. This is being called in ProcessBlock at the start to do the measurement. So this is the audio thread, and this is timer callback. And as you know, timer callback is message thread. There I'm getting the amount of nanoseconds. I should rename this to time though, because I like it to be a little bit more generically named here, because sometimes I like to change this to microseconds. Here you can see me prompting GitHub Copilot. I don't need that anymore. So basically go to the desktop, then go into the folder benchmark and make a file called log and append the text with this time to it. And I also have a little special feature in the destructor where I'm also getting the average value from all of the measurements that have been made in the past by reading the file into the program again one last time to get the average value, and then appending that as well. The timer callback is just on a different thread, so you have a little bit of friction here. Also, people are always not sure if it's a good idea to have something like a steady clock or high precision timer from Chrono in the audio thread at all. So when you are using this class, you can really feel how it is not the perfect way to measure this. But it was also just my first approach. Let me show you. Making a benchmark object here. Now instead of using this, I have to go in my ProcessBlock method and call benchmark, and then it will, benchmark. Let's run this in debug for now. 122001. I mean, that's just weird. Like, first of all, 0. Can it really be that ProcessBlock only takes around 0 microseconds? That makes no sense. And also these numbers in general, that's just not as fast as ProcessBlock should be. So I don't know, it just seems wrong in general. It doesn't fit at all to the numbers that we get with the method that I found afterwards. I must say though, I'm not really sure why. It doesn't matter though, because then I had the better idea. So going back to my benchmark namespace, we can finally look at the ProcessBlock method. In it, I create an atomic duration, an audio buffer and a MIDI buffer. So it is already starting a little bit similar to how it was in this class, where it also started by constructing an atomic duration. But this approach also has its own audio buffer and MIDI buffer, because the idea is to loop through all the iterations that are the input argument of this method. The input arguments have some default values though, and just do the measurement and call ProcessBlock with this audio buffer and this MIDI buffer. Now you can see where this is going hopefully, because if this is called in a method where the audio engine is currently not turned on, and a scenario like that can be created easily, then you can just use ProcessBlock for whatever you want for a while. So I create a file name name, which is the current time plus log. Then I'm going into the benchmark2 folder and the file stuff. And I want to have a min value, a max value, and a sum. So every time the measurements are done, I'm getting the elapsed time. I'm calculating my minimum, maximum, and my sum, and I append the text. When the loop is done, I calculate the average and append all the texts. And since this was all on the same thread, it can just be done without having to think about anything that could get in your way. I'm pretty proud of this because I'm usually not so much the optimization guy, but today it felt really good to dive into this topic a little bit.